In the previous section, we discussed how to find antiderivatives or the indefinite integral of a function. Here, we'll look at a little bit more advanced problems, and really, by a change of variables, what we're really doing is anti-differentiating a chain rule. So here it is. This is the same theorem that you find in your book. Right? We know that if f of big F is an antiderivative, then the indefinite integral of f du is just f of u plus a constant. Well, what if u is itself a function with respect to x? Well, then, right, du would be g prime of x dx. And so still u is g of x, so it's this. So really what it's saying, if I've got an expression that looks like f of g of x times the derivative of g of x dx, then this is just the antiderivative of little f evaluated at g of x plus a constant. So now recognizing this is not always the most trivial thing to do. So it's best to just look at some examples and how we can use this change of variables. So let's say I want to know what is the antiderivative of the square root of 3y plus 1. And I want to integrate with respect to y. So rewriting this, we can see we've got a power going on, 3y plus 1 to the 1/2 dy. So this somehow we've got a power rule going on, but what is the power? What is all the pieces? So what we do is what's called a u substitution. So a u substitution, we're going to let u be this internal function, the function that's inside of the radical. So we'll let u be 3y plus 1. And we're going to change this, we're going to substitute it so that we integrate with respect to u, which means we need to know its differential. So du is equal to 3 dy. Or solving for dy, we can say, oh, well, dy, we could just substitute that with 1/3 du. And now this integral becomes something like, I can rewrite it as this being equal to the integral of u to the 1/2, since that u is exactly what 3y plus 1 is. And then dy can be replaced with 1/3 du. So this is times 1/3 du, or in more natural form, I can take this constant factored out. So this is 1/3 times the integral of u to the 1/2 du. And now we can use our power rule. We add 1, so this is equal to 1/3. So it'll be u to the 3/2. And this will be multiplied by 2/3 plus a constant, which is equal to, right, 2/9 u to the 3/2 plus a constant. And quite often students will stop here, but recall we wanted to know what is the antiderivative with respect to y. We've got everything in terms of u, so we've got to put this back in for u to call it our final answer. So our final answer will be 2/9 times the quantity 3y plus 1 raised to the 3/2 plus a constant. That is the antiderivative, or the indefinite integral, of root 3y plus 1. Okay, so what we do, as I said, is we do a u substitution. And the key move here was recognizing what function is inside of the exponential function, right? What was the inner function? In this case, it was 3y plus 1. So that's your goal anytime doing u substitution. So if I'm looking for the antiderivative of 4y divided by, say, 2 plus 3y squared, and I'll square that. And I want to know what is the indefinite integral of 4y over 2 plus 3y squared squared. So investigating this function, what will be my internal function? Well, a first guess would be, let's let this be u. So 2 plus 3y squared itself is being squared. So if I let u equal 2 plus 3y squared, what is du? Well, the differential of u would be 6y dy. Like you did before, I'm going to solve for dy because I need to figure out what to replace this differential with. So dy is equal to 1 over 6y du. And so putting those two pieces back into my equation, this indefinite integral is equal to 4 over u squared times 1 over 6y du, right? Because that's what dy is equal to. And the y's cancel, the 4 becomes a 2, the 6 becomes a 3, and so I can rewrite this as 2/3 the antiderivative of u to the negative 2 du, which is equal to 2/3 times u to the negative 1, and so I get a negative in front, plus a constant. But I'm not done. I can't stop here because the u needs to be put back in terms of y, and so this is equal to negative 2/3 times the quantity 2 plus 3y squared raised to the negative 1 plus a constant. That's our final answer. Let's do some more. Really, u substitution, you get good at u substitution just by doing u substitution. So to get good at this, you just have to do lots of examples because u subs can come in all shapes and sizes. So let's look at sine squared of theta times cosine of theta, all with respect to theta. Well, I want to remind you that sine squared theta, so this, if I wrote it this way, maybe it's more clear that I've got sine of theta, that function is being squared, times cosine of theta with respect to theta. And hopefully when I write it that way, our first guess should be, let's let u be this guy, right? Because I've got sine inside of the exponential function. So if I let u be sine of theta, then du, so the derivative of sine is cosine, d theta. And I recognize, oh, that actually term is right there. This is du. So in this case, I'll just write this out as the antiderivative of u squared du, which that's a straightforward, simple power rule. So this is 1/3 u cubed plus a constant. And now putting the sign back in for u, this is 1/3 sine cubed of theta plus a constant. Let's do another one. So let's determine what is the indefinite integral of x, say x, e to the 1 minus x squared with respect to x. And for u substitution of work, I've got to find out what is the internal function. I've got a number of functions going on here, but namely, I've got 1 minus x squared in the exponential function, right? This is going to be my guess for u. So let's let u equal 1 minus x squared. Then du is equal to negative 2x dx. And again, kind of like I've done before, I'll solve for dx. It is equal to negative 1 over 2x du. So I can put this in for dx. I've got my expression for u, or 1 minus x squared. So this is equal to the integral of x e to the u times negative 1 over 2x dx, or du, sorry. And this x and that x cancel, giving me a remainder of negative 1 over 2 integral of e to the u du, which I know how to antidifferentiate that. That's just negative 1/2 e to the u plus a constant. And then putting 1 minus x squared back in for u, the final answer is negative 1 over 2 e to the 1 minus x squared plus constant.